Hi everyone, it's Mr. H here, and today we're going to look at what happens to sine, cosine, and tangent when you make an angle bigger than 90 degrees. Up to this point, we've only applied these to triangles that have a 90-degree angle, and so we haven't had any of the other two angles be bigger than 90 degrees. Well, we can actually have one of the other angles be bigger than 90 degrees, as we'll see today. Our goal is to determine a pattern of sines, of the positive and negative signs, of trigonometric ratios in each quadrant. So we're going to try to identify, looking at different quadrants. This is quadrant 1 here, and then quadrant 2, quadrant 3, quadrant 4. What are sine, cosine, and tangent? Are they positive, and is sine always positive in a certain quadrant? Is cosine always positive in a certain quadrant? Is tan always positive in a certain quadrant? So we're going to see what quadrant are they consistently positive in, and what quadrant are they consistently negative in. That's the goal of what we're trying to do. Now you'll notice here that because we're starting at this positive x-axis, we're going to always measure our angle from that around to what we call a terminal arm. You can see that drawn in the picture below. So this is going to be the principal angle. We're going to call that theta. And as you can see in the picture below, if we're outside of the first quadrant, we're always going to draw from the terminal arm down to the x-axis our related acute angle, beta. So we've got the principal angle that's measured from the positive x-axis to where the terminal arm is. And then we've got this related acute angle, beta, that is going to always go to the closest part of the x-axis. So over here in the second quadrant, it's going to go down to the negative x-axis. So we're going to apply these special triangles that we learned in our last lesson to see what the signs of the sine, cosine, and tangent ratios are in each quadrant. Now here we go. So the first one is this. And for a 30-degree angle in quadrant 1, this is our first quadrant, we will always have the ratios simplified to the following things. This will be 1, this will be 2, and this will be root 3. It's easy to mix up your 2 and root 3 with this special triangle, because we think 3 is bigger than 2, but root 3 is smaller than 2. So keep that in mind that you're labeling that properly. So what is the sine ratio of this going to be? Well, sine is opposite, which is 1, over the hypotenuse, which is 2. So it ends up being that. What I'm most concerned about is the fact that it's positive here. The next one, cosine, adjacent over hypotenuse, 2 over root 3. Again, it's positive. The tangent, opposite over adjacent, it's 1 over root 3. Again, it's positive. So we can see in the first quadrant here that both all of sine, cosine, and tangent are all positive. Now you might wonder, well, you didn't rationalize the denominator, Mr. Hamilton. Well, you know what you need to do in this case is just care about the signs. That's all we care about. The fact that this one is a positive, they're all positive in this particular case. So we don't need to rationalize the denominator to figure it out. You could, there's nothing wrong with doing that, but that's all we need to do is look at the signs. The other way I want you to do this as well is I want you to look at this with your calculator. If you put in an angle of 30 degrees, make sure your calculator is in degrees. If your calculator is not in degrees, this is a problem. We're going to go sine of 30 degrees. Well, what's sine of 30 degrees in your calculator? Well, when I type it in, I get positive 0.5. Well, what's cosine of 30 degrees? Well, when you type that in your calculator, you should get positive 0.8660. What about tan? Well, when I type that in, tan of 30 degrees, I should get the same thing again. I should get positive 0.5774. In other words, these are the rounded answers that are given exactly above. But the point that we're most concerned about here is the signs. They're all positive. If your calculator doesn't give you the same number as you come up with from the diagram, be wary of that, because they should give us the same values and the same signs. All right, let's take that related acute angle and let's put it in quadrant 2 now. So here we go. If I put this in quadrant 2, my related acute angle of 30 degrees means I would have a principal angle of 150 degrees. And what this down here is representing, this length here, is it's representing the length of the x. But it's representing it according to the coordinate the x would be. So out here, the x would be negative root 3. The y up here would be a positive 1. And the distance from here to here, we call that r. That is going to be 2, because that's always going to be positive, representing the length of that. So with all this in mind, I can go and I can figure this out. Sine is opposite over hypotenuse, so 1 over 2, again positive. Cosine is the adjacent over hypotenuse, so it's negative root 3 over 2. It's negative. And tan is opposite 1 over adjacent negative root 3. So this is going to be negative as well. So we can see in the second quadrant then that sine is positive, but cosine and tangent are negative for this 30-degree related acute angle. If you on your calculator go ahead and you put in sine 150, you should find an answer of 0.5, positive. If you put in cosine of 150, you should get an answer of negative 0.8660. Negative. Make sure that's, note, the same sign there. And if you put in tan of 150 degrees, you get the same thing again. Not the same value, but you get the fact that it's negative. So 0.5774, negative. So we can see that these, in this second quadrant, are negative. Let's keep going with the next two quadrants now. I'll just leave that one there so we can see what we did to remind ourselves of the next one. So again, here we have it, and we are going to have a length of 2 here. It is now negative 1 because the y value would be negative down here. And then from here to here is negative root 3 because the x value would be negative there. The related acute angle is 30 degrees. The principal angle is 180 plus 30, or 210 degrees. So here we go. Sine, cosine, tangent. Sine, opposite over hypotenuse. It's negative 1 over 2, negative. Cosine is negative root 3 over 2. Tan is negative 1 over negative root 3. Well, negative divided by negative cancels out, and I get positive 1 over root 3. So sine and cosine were negative in quadrant 3 for this related acute angle, but tan was positive. So there are my negative ones. Do the same thing in your calculator. Sine of 210 degrees, what do you get? Sine of 210 degrees should give you negative 0.5. Cosine of 210 degrees should give you negative 0.8660. And then tan of 210 degrees, if you've typed that in your calculator properly, should give you 0.5774, a positive value. So we can see there that not only is the sine matching up with the what we found as our ratios compared to what we're doing on our calculator, you should also notice that these values are all the same. 0.8660, 0.8660, 0.8660 for cosine. For sine, 0.5, 0.5, 0.5. And for tan, 0.5774, 0.5774, 0.5774. The only thing that's changing is the sign, the positive or negative. The reason for that is because the ratio is always the same numbers, but sometimes one is positive or negative. Go ahead, pause the video, and see if you can do the last one, and then check your answers with me when you're done. So hopefully what you found is that you got negative for sine, you got negative for tan, but positive for cosine. So in this fourth quadrant, we ended up with, for this special angle of 30 degrees, we ended up with both sine and tangent as negative. So what you're doing now in the rest of this investigation is you're doing the same thing now with the other special triangles. You're using the two other special triangles, and you are drawing the picture, finding what it is based on the picture, and then you can also use your calculator to confirm that. So I could have done that for this previous one, sine of 330. That gave me negative 0.5 on my calculator, and do that to prove that to yourself. Cosine of 330 gave you positive 0.8660, and tan of 330 gave you negative 0.5774. So that's what you should have gotten in your calculator. Let me draw the second one for each of these so we can see how this works. The first one's pretty intuitive. I'll draw the first and second one. So this one's a 45-degree angle, and we know from this that this is 1, 1, and root 2. For the next one, it's going to be in the second quadrant. So again, the related acute angle of 45 degrees. This is positive 1. This is negative 1 because the x value would be negative on the negative side. And this is 2 again, always positive 2 for that distance of that terminal arm. And then if you continue doing that, the next one's going to be down here. This is going to be negative 1 and negative 1 and 2. Again, this is 45 degrees here. But you can see there that in this case of the 135-degree angle, that's 135. And in this case here, you're going to go 180 plus 45, which is going to give you 225 degrees. Keep going to the next one. We're going to put it in the fourth quadrant now. 45-degree angle. This is going to be 315 degrees. Yes, you guessed it. This is going to be negative 1, positive 1, and 2. So with those, you can figure out the ratios for that special triangle, that angle of 45 degrees. And let's go ahead and draw them for the next one as well and see what we get. 60 degree. It's going to look like this. This is 1, this is 2, and this is root 3. That's a 60-degree angle. The next one, 120. It's going to be this one here. So this is 60. It's 120, always measured from the positive x-axis. And this is going to be negative 1, because the x value would be negative on that side. This would be root 3 over here and 2. If I put that 60-degree triangle in the next quadrant, this angle is 60 degrees. That's the related acute angle. This theta, this is the principal angle, is going to be 240 degrees because we have 180 plus 60. This is going to be negative 1. This is going to be negative root 3. And this is going to be positive 2 because it's the negative x and a negative y. And the last one here is going to be in the fourth quadrant. So if I go all the way around to here, and this is a 60-degree angle, then theta is going to be 360 minus 60 degrees, or 300 degrees. So that last one, 300 degrees. This is negative root 3. This is positive 1 along here because it's now a positive x value, and this is positive 2. So go through that with your calculator and with just using the logic that I described earlier and see if those start forming a pattern. You want to look after filling in the charts and see and conclude the following things. Look at the signs of all the ratios, not rations, but the ratios for the principal angles in quadrant 1. Which ratios are all positive in quadrant 1? Which are all positive in quadrant 2? What about quadrant 3? What about quadrant 4? From that, see if you can derive a rule that allows us to know what ratio is positive in which quadrants. And we'll take this up in class tomorrow.